In this video, we're going to do another chi-squared analysis of data sets. And the reason we're going to be using the chi-squared test is because we're looking at data that's going to be all categorical, and the natural test for whether the proportions in that data are consistent between different categories is going to be the chi-squared test. This time we're going to be looking at criminology data. And so we have our districts in a town, and we have different kinds of crime. We don't see a lot going on here, so it makes sense to do a few basic analysis questions. So we'll put print statements around these things so we can see more than one. And data. So this is this is a reasonably large data set with 2,000 entries, so we probably don't want to look at it one by one. So remember the other tools that we had, which are to identify the value count. So if we look at the district category, and we ask how much of each output or how much of each category is in that column, we get that there's a south district, a north district, and a center district, and how many reports come from each of those. So the south seems to be the most heavily represented, and the center has the fewest samples. Then we can do the same thing again with our crime type. So again, the nice thing about the head is you can get all your columns there. And here we see that they've got 3 different categories of crime in the database: larceny, assault, and burglary. And larceny seems to be the most common. I had to look this up. Larceny is typically, it's theft, but a more broad thing than burglary. Burglary is more breaking and entering into a building. Larceny is about just stealing stuff. So stealing a bike from a porch would be larceny. Breaking in to a house to steal things would typically be burglary. And I'm not a lawyer, so there we go. That's my limited understanding. So the next thing we're going to do is try to ask, well, are there different crime type proportions in different districts? So let's do a quick data analysis here, and we're actually going to call this observed counts. And this is going to be our crosstab thing. So our crosstab of the 2 data types that we want. So we're going to cross the district with the crime type and see what that looks like. And we're going to print it so we can actually see it. Observed counts. Perfect. So what we see here, if we look in the assault category, we see 300, 600, and 610. Oh wait, that adds up to the 612 that we had from our summary. And likewise, the burglary and larceny totals will add up to these. If we add up across the rows for all the districts, we'll see that the south, in fact, has the largest number of counts here. And it adds up to, not surprisingly, 1,642. So that's the basic gist of what we want. We now know the layout of these proportions, and it certainly seems like let's look at each category. So it looks like assault is most common in the south by about 20. That's really hard to gauge. These kind of look like they might be the same proportions, even though the counts are different. And it's really hard to judge because the totals in each column and row aren't consistent. So enter our tool from before. This time I'm actually going to copy it from our earlier example. And this is where we bring the statistics. So we're going to use the SciPy statistical test for a contingency table. We've changed our data set now to be called observed counts, or our table of observed counts to be that. So we're going to run this, and then we're going to print our p-value. And again, we might as well borrow that one line for how to print it nicely. And there we are. Oh my, let's get to like 8 digits here. Oh my, this is a very, very small p-value. Okay, so what's the story again? The null hypothesis is that all districts have the same proportion of crime types. Proportion of crime types. Okay. So someone from the city's council office is saying, we should just be doing the same kind of policing everywhere because everyone has the same fraction of burglaries, larceny, and assaults. There's no point in changing things up. Everything's basically the same. It's more frequent in one district than another, but the kinds of crime we're seeing is the same. This p-value says the probability of seeing this data if that claim is true, if those people are telling you their truth, is so fractionally tiny that we can't even imagine it. So there is no way that this null hypothesis is true if what we see in the data is real. And since we trust our data, we reject the claim that someone made. Now, I think it's really helpful here to dive one step deeper and go, okay, so the p-value tells us that, but it'd be really helpful to look at why that is, like where are the differences specifically. Was the typical follow-up example or follow-up analysis. Let's look at what the expected values would be if the claim were true, and then see where we deviated in our data set. So let's take a look at that. And actually, let's put them all on one table here. And we'll add some extra print statements in between just so it's more clear what is. All right. So print. Actually, I think we can do this. No, do this way. Observed. And then the expected. And then the differences. All right. So, right off the bat, if the proportions were the same, we would have expected to see 96 assaults in the center district. We saw 140. And so the difference there is actually pretty huge. It's 43 relative to what we expected, which was 96. So that kind of difference is unexpected and would be very rare to have that kind of difference if the claim that everything was the same in all the districts was always true. So what we get out of this analysis is that, especially in actually in all the districts, the center district is overrepresented for assaults. The south district is underrepresented, has 36 fewer than we'd expect. Larceny has the opposite pattern, that it's much less common in the center, much more common in the south. So that kind of analysis lets you then do a follow-up question. Okay, so things are not the same. Where are they different? And then what should we act on based on that? So that's a nice sort of vanilla approach or vanilla analysis of a case where there is a significant difference in the proportions, and then we can do some quick eyeballs on the dataset layout. How many reports in each district we have, how many reports of each type of crime do we have, and then specifically where are those kinds of crimes over and underrepresented through this comparison of the observed versus the expected counts.